Okay, let's talk about some of these calculations. If you're familiar with statistics, this will be easy. If you haven't done it in a while, maybe you'll pay attention a little closer. I'll also do a spreadsheet version of this so you can see it in a spreadsheet on how to calculate this. But let's get to it. So, individual securities. Individual securities are that are of interest. We can know the expected return. We're going to calculate a variance and a standard deviation, and then separately we're going to calculate the covariance or correlation as the securities move against each other. So when we start thinking about covariance and correlation, remember I told you they can move independently of each other, and what we like is them to not be correlated. In other words, when one goes up, the other one goes down, and we like that negative correlation in there, because if you turn it on the side, your portfolio stays constant as the stocks bounce all over the place. So your returns stay constant. That's what you're looking. That would be helpful if you could find that. So let's go beyond that and do some math here. So the first slide is expected return, variance, covariance. Here's our scenario. We have two risky assets. We have a stock fund and a bond fund. There's 1/3 of a chance of the economy going either into recession, staying normal, or booming. So the probability is 33.3%. If we have a recession, the stock fund will do poorly at -7, but the bond fund will do well as the money moves out of stocks and into bonds. Normal times, the stock fund gives you 12%, bond fund gives you 7. And of course, when we have a boom, the stock fund will go up quite a bit, and the bond fund will lose a little bit of money. So when you start thinking about exactly what's going on, we have two options here, stocks and bonds, and we have three types of economic activity going on. And so what we're trying to do is figure out what we would like to do with this scenario. How do we want to invest? So we have to do some calculations. So this next slide, the expected return slide, shows you all the calculations we need to be able to do. And these are quite simple here, but we'll take them one at a time. So the givens are the rate of return for the stocks and the bonds. Now we saw that, -7, 12, 28, 17, 7, and -3. Everything else here is calculated, and we're going to take it step by step and calculate each one of them separately, and so it'll be really easy. It's very easy math. The first thing we can do is expected return. So expected return is simply an average, and what we do is we take the -7, the 12%, and the 28%. I've shown it here multiplied by 1/3 when it's actually just divide by 3. So you can see that -7, 12, and 28. 12 and 28 is 40. -7 is 33. Divided by 3 is 11. So you could have even done that in your head. So the multiplying by 1/3 is just the way I showed it in the slide because I couldn't divide a line. It was too hard to put a line underneath that word. I just multiplied 1/3, which is mathematically correct, but not the way you'd normally do it. So you simply add them together and divide by 3, which, if you were paying attention to previous slides, was your arithmetic average. So we're using the arithmetic average to get an expected return of 11%. Let's move past that. Oh, and incidentally, before I move past the slide, we did the same thing in the bond slide, right? The bond slide had 17 and 7, which is 24, -3 is, 77 is 24, -3 is 21. 21 divided by 3 is 7. So that's how we got the 7%. Variance. The variance is the squared deviation, or the squared deviations. The sum of them is the squared variance, so we have to square the deviation. So we take the 11% expected return, and we find out how big of a deviation that is from the rate of return. So -7 minus the expected return, the deviation from the mean, -7, the deviation from the mean of 11. So -7 minus 11 in parentheses squared. So -7 minus 11 is -4 squared equals 0.324. So that is the squared deviation from the mean. So in the recession scenario for the stock fund, the deviation from the mean, squared deviation of the mean, is 0.324. Now you simply do that for every other number here. So the normal return would be 12 minus 11 is 1. 1 squared is 1. They 0.0001 there, but it's basically 0. The expected, or 28. 28 minus 11 is going to be 17. 17 squared is 0.0289. So you can see how the math works. This is, it'd be easier even to do it on a spreadsheet, but this is how you figure out the squared deviation. Once you have that, we add up the squared deviations and divide by 3. Again, I've multiplied it by 1/3, which is 0.0205, which is the variance. Now the variance is a very interesting number because to get to the standard deviation, you probably already know this, the variance is simply take the square root and we get the standard deviation. So you can see that in the next slide, which is the square root of 0.0205. You square root it, gets you 0.143, which gets you 14.3% as your standard deviation. Well, now we have standard deviation and an expected return. And a standard deviation and expected return here will tell you a lot about the distribution of these characteristics of these two funds. So for the stock fund, we have a standard deviation of 14.3 and an expected return of 11. So 11 is in the standard, in the center of the distribution, and one standard deviation on either side is 14.3. So 68% of the time, this stock fund is 11 plus 14, 25% of the upside, and 11 minus 14, minus 3% of the downside. So minus 3 to plus 25, 68% of the time, or 2/3% of the time, the stock fund, that's the return you're going to get. So you can see how the distribution curve plays a role in figuring out what the returns will be going forward in your investments. Now, obviously, they've done the same thing for the bond fund. And so we've got a standard deviation of 8.2, an expected return of 7%. So the bond fund, if you have a mean of 7, within one standard deviation, or 68% of the time, it will be between 7 plus 8.2 is 15.2, or on the downside, it'll be 8.2 minus 7%. So 68% of the time in the bond fund, you still have a positive return of 1.2 on the downside and 15.2 on the upside, which is pretty nice to have. That's why people feel bonds are safer than stocks, because more times do you have a positive return. They're less volatile. So now we've got both of those things. We have our expected return and our standard deviation. Let's move on to correlation and keep going.